Rocky, shh.
So we were talking about right angled triangles, not just triangles, but we were specific right angled. A squared plus B squared equals C squared. That seems familiar. I'm going to write that down. But do I remember what it means? And Daniel mentioned about that big word that sometimes I can't spell correctly. Sometimes I can't even say it correctly. Takes a bit of practice though. So you've got the hypotenuse. You've got A squared equals B squared equals C squared. So that's the Pythagoras theorem. He said that in a right angled triangle, A squared plus B squared equals C squared. We named this as our hypotenuse. Yeah. And what did we call these again? Legs, or because the hypotenuse would be the longest side, these are what we call the shorter sides. Yeah, so those are the legs or the shorter sides of a right angled triangle. Okay, now we saw this formula in action last lesson because we solved some unknown sides of a right angled triangle, specifically when we have what, a right angled triangle such as this one here. We've got, let's say this is 3, this is 4. What do we have for our C here, which is our hypotenuse? How do we use that formula again? Yeah, so we've got 3 plus 4, and would that be 7? What are we forgetting? Is it 3 plus 4? So we say C is 7, or is it something else? If you want to get C, you add 4 squared and 3 squared. We need to square each of the numbers first before we add them together. To square 3, and then we square 4, you get 9, and then you add 16, you get 25. Yeah? How do I get C? Because I don't want C squared, I just want C. So you get the square root of 25, we get C equal to 5. All right, so we've got the legs to be 2 and 7. So we've got C squared, we start with that. It's equal to 2 squared plus 7 squared. And we use our calculator, we put 2 squared, you get 4. When you press on your calculator 7 squared, we learned a while ago, it was 49. Who remembered that? And 4 plus 49, what would that be? 53. And we've got C squared equals 53, but we just want C, and therefore we put the square root of 53. And what would that be? Yeah, so 7.28. You might want to write 2 decimal places there. How did you go with the work from last lesson? It's very similar to what we're doing now. If you would be looking at our learning intention, it would be just the same as what we had last time. We're still applying Pythagoras' theorem. But if you look at the title, what does it say? It's a bit different for the title. It says finding the shorter side. So now, previously, we were looking for what? We were looking for the longest side, the side that's opposite your right angle, or what you call your hypotenuse. But this time, the one that's missing would now be one of the shorter sides. How do we do that? We'll have a look. We'll have to use and play around with our Pythagoras theorem there. Let me go straight to examples of how we will be able to find the shorter side. Let's have that example drawn here. So we've got the 12, we've got the 9, right? We know that the hypotenuse, we said last lesson that the hypotenuse would always be the longest side, and we know where that is because it's located, what? opposite our right angle, that this is our hypotenuse. So now we've got one short side. Let's probably just call it A. We can call it B. It doesn't matter. A and B can swap together, right? But we would need to establish what C is, right? Because there's only one C in our right angle triangle. We remember that our working formula is C squared equals A squared plus B squared. But we want A squared by itself. What we want to do is to get rid of this B squared here, right? But you won't be able to just get rid of it by just crossing it out, right? You have to maintain that balance, because there's a balance there. You're saying that the left side is equal to the right side, correct? For you to get rid of the B squared, it says there it's plus B squared, yeah? What's the reverse of plussing? Minusing. We want to minus B squared to get rid of that. But to maintain that balance, right, what we do on the right, we also do on the left. So if we minus B squared here, we also want to minus B squared on the other side. So what do we have now? C squared minus B squared is equal to A squared. And this now becomes 0. So that vanishes, right? Now, normally, well, we know that if the left is equal to the right, then right is equal to the left, yeah? So we can just swap them around and say A squared equals C squared minus B squared. Does that make sense? Okay, this now is our working formula. We're applying still our Pythagoras theorem, right? It's just renaming it, okay, so that it will suit our needs, okay? What is our need? What do we want to find out? We want to find out the shorter side. We don't want to be finding out the hypotenuse anymore. We want to find out the shorter side, yeah? So now we've got A squared equals C squared minus B squared, okay? So when a shorter side is the one that's missing, we use this formula instead. How do we use it? Let's continue our working here. We replace what? A squared, we replace C with 12, because that's what it says here. Yeah, B squared. And then we replace B with 9, so 9 squared, right? And just like what we were doing before, we square the number, we put 12 and then the square button, we get 144. We minus, we put 9 and then the square button again, we put 81. And then what do we get for 144 minus 81? 63. And now we still have A squared there. For us to figure out what A is, we just get the square root of 63. So again, this is in exact form. With this one, if we've got the shorter side, that's the unknown, what do we need to do? It's a minus, right? But if the hypotenuse is the one missing, then it's a plus. What am I referring to? That's the plus there, right? Whilst this one here, there's the minus there, okay? Yes, so that's the big difference between when you're looking for the hypotenuse and when you're looking for the shorter side. Let's have this example here. It says a ladder that is 4.5 meter long leans up against a vertical wall. The foot of the ladder is 1.2 meters from the wall. How far up the wall does the ladder reach? Give your answer correct to decimal places. Okay, so when you have these word problems here, the one that will help you a lot in solving it would be drawing an illustration of what the problem describes, okay? So you don't have to draw them like this one here with wherein you've got that ladder, beautiful ladder, and also the wall with bricks, okay? You can just say, well, this is my ladder here, right? It's leaning against the wall like this, yeah? So that I know that there's a triangle that's formed between them, and it's not just a random triangle, but there's something special about that triangle. It is a right angled triangle. And what does it say in the problem? The ladder is 4.5 meters long and it's leaning to a vertical wall. The foot of the ladder is 1.2 meters from the wall. So this is the foot of the ladder, right? That from here would be 1.2 meters. So now I've got two known sides and I am looking for the shorter side. We said that if we're looking for the shorter side, we use this working formula and it's a minus. This time it's c squared minus a squared. With which one is c? And how do I know that that's the c? 4.5, yes. Why do I know that that's my C? It's the longest side, but how do I know it's the longest side? Maybe B is the longest side. Maybe B, for all I know, is 7.2346. I just invented that number. It's the hypotenuse. How do I know it's the hypotenuse? It's not only the longest side, but also where is it located? It's opposite your right angle. It always faces your right angle, okay? So that I know is my shortest, is my longest side, yeah? So now I can write and replace C with 4.5, put the square in, minus 1.2, put the square, and that I won't be able to do that in my head. I need my friendly calculator. And what do I get? 4.5 squared is 20.25. Thank you. Minus 1.2 squared. What do I get? 1.44. Thank you. And what do I do? Or what do I get when I minus them to how many decimal places? To 2 decimal places. Oh, hang on. We minus them. What do we get? 18.81, but that's b squared. I'm not done yet because I want the square root of that. 4.34, well done, because it says there it's 4.337. Round the number to 2 decimal places, right? Because the next digit is a 7, we round up. I want your questions on Friday, okay? See you later, guys. Come on, Rocky. Let's go.